Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot. So go ahead and click the subscribe button. That said, let's get into the current video. In this video, I want to talk about why can we separate a differential equation. In your differential equations course, you maybe have learned about separable equations, which are differential equations that look like the following. So a separable differential equation is one that satisfies the following. The derivative is equal to a product f of x times g of y. So what that means is the collection of variables or terms that have the variables in them, I can write as a product of an expression in x times an expression in y. And once I do that, I can use the separation of variables technique. For example, let's say I have dy dx equals x y squared. Okay, something like this. Now, in order to separate this, what I do is I divide both sides by y squared and I multiply by dx, so I get the following. Dy over y squared is equal to x dx. And then we go and from there and solve the equation by integrating both sides and solving for y if possible, so on and so forth. But what I want to focus on in this video is we multiplied by dx. Well, we learn in Calc 1 that dy over dx is not a fraction, it's one thing. So why can I now multiply by dx? So why do we multiply by dx? That's what I want to explain. Okay, so let's say I have the following. I have this separable differential equation, and let's separate it as far as just putting the g of y on the other side. Okay, so we have 1 over g of y dy dx, I'm going to leave that as is equal to f of x. Okay, now what I'm going to do with this is a function, and this is a function, and we can integrate those. Let's integrate those with respect to x. So I'm going to compute the integral of 1 over g of y dy dx with respect to x. And I'll do the same thing on the other side. Now the other side I'm not really focusing on at the moment because I'm worried about multiplying by the dx term, but I'll just carry that along. Now, within this equation right here, here's what I'm going to do. I'm going to do a change of variables, in other words, a u substitution. Remember that y is a function of x. So what I'm going to do, let me pick a different color here. Let me see if this one has any ink in it. So let's say u is equal to y. And remember, y is a function of x. So when I take the differential du, I get dy dx dx. Now let's take that and substitute that back into the integral up above, and what I get is the integral of 1 over g of u. Now dy dx dx, that combination right there, right, that is du. So this is 1 over g of u du, and the other side was integral of f of x dx. Now I'm going to clean up the side over here, but I'm going to talk while I do it. Remember that the variable in an integral is a dummy variable, right? So what that means is I can replace it with any variable I like. And in particular, let's replace u with y and see what we get. So if I go ahead and replace u with y here, I get the integral of 1 over g of y dy is equal to the integral of f of x dx. And notice what happens if I look at this differential equation right here, this is when I separated just by multiplying by the g of y, or dividing by g of y. What I did is so multiply both sides by dx. It looks like I get 1 over g of y dy equals f of x dx. But the main thing is I'm going to then integrate that. So we can, using a shorthand notation, just take this dx and throw it over here because I'm going to integrate it in the next step. So really, if I was to kind of do that and integrate in the same step, that would kind of bypass the multiplying by dx operation. But that's why I can ultimately do it, is because ultimately when I do a change of variables down here, I get the expression that I expect. And so when we solve these separable equations, we just pretend like we're allowed to do that, because in the end it's going to work out to be fine anyway. Thank you for watching. Please consider subscribing.